Applications involving normal distributions. So we're going to wrap up our look at normal distributions by solving applications, and we're going to do that using Desmos. Let's review quickly what we know. We know what a standard deviation is. It's a typical distance between an individual data item and the mean. And we know what a normal distribution is, a graphical display of data in which the data tend to cluster symmetrically around a central value, which is the mean, and we kind of come up with a bell curve shape. We're going to see this beautifully in Desmos. Okay, so in Desmos, they had this delightful function called the normal dist function, which, as you might imagine, stands for normal distribution. And in the normal distribution function, you put in the mean and you put in the standard deviation, and it will create a normal distribution based on that mean and that standard deviation. And you can use it to find percentages above, below, and between data values. It's actually quite nice and very simple once you kind of get into it and do it once or twice. So example number one here, you're only going to need one example to see how this works. The lifetimes of a certain type of watch battery are normally distributed with a mean of 400 days and a standard deviation of 50 days. Okay, what percentage of batteries will last A, between 360 days and 460 days, B, more than 320 days, and C, less than 280 days? Well, let's first take a look at the normal distribution that has this mean and this standard deviation in Desmos. So I'll come into my pad here, straighten it out, I hope. I'll open up Desmos. Okay, so in the top right again, we're going to put it in. We'll putting something up in this row here. Let's go to functions. Normally it opens up to the trig functions. You want to go to the dist functions, which I think stands for distributions. And you'll see here under the distributions, we have the normal distribution right there. The first button will press normal distribution. And it tells you that you want to put in the mean, comma, the standard deviation. That currently what you see here has a mean of 0 and a standard deviation of 1. That's the reason it's sitting here right at 0. Let's put ours in. We have a mean of 400 days. We're going to type in 400, comma. Our standard deviation is 50 days. And I'll close the parenthesis. And you'll notice that we're not on the graph anymore because this graph goes from -10 to 10 in the two directions. And our mean is 400. So let's press the zoom button here, this magnifying glass with the plus. And there you have it. There is our normal distribution with a mean of 400 and a standard deviation of 50. Now, we can use this to solve problems. We can use this to find probabilities as long as we check this find cumulative probability checkbox. So I'll check it. And it says to you, first, we're looking at its default is to go from -infinity to infinity, which is 100% of the data. That is why it is entirely shaded. I could kind of go like this, and it goes on forever to the left and to the right, even though there are fewer and fewer values there. We tend to focus on, of course, 3 standard deviations above and below, because that's where the vast majority of data is located. So now let's take a look. So I'm going to put this aside just for a moment. We'll come right back to that. And our problem says to us, problem A, we want to be between 360 and 460. So we want to know that this is our min and this is our max, what percentage fall in between those two? Okay, let's go to Desmos. And this is simply done. Desmos currently has a minimum and a maximum of negative infinity and infinity. We want the min, so we'll press min to be 360. And you can see it's already cut off. It's already now looking at 360 and above. It's already taken away what's below 360. But we want our max not to be infinity, but we want our max to be 460. So I'll tap here and I'll put in 460. And Desmos shades for you the percentage, the area under the curve that represents the percentage of 1. The entire area under the curve is 1. So this area is the area we're looking for, and it gives us the answer as a decimal. Okay, so the percentage here is written as a decimal, which looks like it's 0.673. I'll go to the 10th, which would be 67.3%. So what percentage of these batteries will last between 360 and 460? Well, quite a few of them, 67.3% according to Desmos. So we'll go back to here, and we just use Desmos, and it's told us the answer is here is 67.3%, again rounded to the nearest tenth. Okay, letter B. More than 320 days. So greater than 320 days. What percent will last greater than 320? Okay, let's go back to Desmos. So greater than 320 means that 320 is a minimum. Okay, so I'm going to type into the minimum here 320. And I've got this max. Well, I want to go all the way to infinity. I have two choices. I can leave it blank, and it'll automatically go to infinity. And you can see it's 94.5% to the 10th. Or if you prefer and you want to see that infinity sign, you can go into the ABC keyboard and you can type in infinity. I-N-F-I-N-I-T-Y. So if you prefer to see from 320 to infinity and have the infinity there, you can type in the word infinity to see it. But it doesn't matter. It's still showing us that a tremendous percentage of the batteries, because of the shaded region, only this little area to the left is not shaded. From here, from here all the way to positive infinity is 94.5%. So 94.5% of the batteries will last more than 320 days. Okay, I'll move that, and we can answer that question right here. And the answer is, what did I say to the 10th? 94.5%. 94.5%. Letter C, less than 280 days. So less than 280. 280 is a maximum. We want to know to the left of that in the curve, under the normal distribution. So we'll go back to here. And we'll take, let me straighten this out again for you, and we'll go back, and we want to have a maximum of 280. And I'm going to mess up, and so you can see it automatically underlined it in red and said something's up here. Your minimum is larger than your maximum. See the underline in red. I can either leave it blank or I can type the negative sign and infinity. I'll leave it blank. And you can see here, my goodness, this is the part. I'm even going to zoom in a little bit. Well, looking at it here, this is the little bitty section, the area under this curve of the batteries that will last less than 280 days. And their percent is less than 1%. It's actually 0.8% to the 10th. Now we, of course, can come in a little bit tighter if you want to. And you can see there is a part here. You know, it's there. Okay, but that part of the curve, when we look at the entire curve, from positive infinity all the way to negative infinity, that the area under the curve here is about 0.8% of the total area under the curve. And so we just answered that letter C question. What percentage of the batteries in this distribution will last less than 280 days? And we came up with, to the 10th, 0.8%. So there you have it. The Desmos function, normal distribution, allows you to put in the mean and the standard deviation and then answer all these percentile questions or all these percent questions that a lot of people might ask.